All right, let's talk about a day that completely flipped the script. I'm not just talking about a tech update. I mean a day that changed our fundamental understanding of reality itself. A day when the laws of physics, well, they didn't just bend, they practically snapped. You're going to want to remember this date, October 22nd, 2025. Seriously, circle it in your mental calendar. This wasn't just some random Tuesday. This was the day scientists confirmed something that for years, pretty much everyone said was absolutely impossible. So when you hear a quote like that, it bent the laws of physics, it's really not an exaggeration. We're not talking about a faster computer chip here. This was something so much deeper, something that forced us to literally rethink the textbooks on how the universe actually works. So what actually happened on this turning point in history? Well, Google's quantum chip, which they call Willow, finally did it. It achieved what's known as verifiable quantum advantage. Now, what does that mean? It means it solved a problem that our biggest, baddest supercomputers, the ones that fill entire rooms, couldn't solve if they ran from the Big Bang until today. Yeah, longer than the age of the universe. That's a turning point. But here's the kicker. The speed was incredible, for sure, but that wasn't even the biggest news. The real bombshell, the thing that made physicists' jaws hit the floor, was that this breakthrough completely shattered a fundamental law of thermodynamics, a law that had been rock solid, totally unchallenged for 200 years. Okay, so for 200 years, physics had this rule, right? It's called the Carnot limit. Think of it like a speed limit for energy efficiency. No engine, no matter how perfect, could ever break it. It was considered an absolute unbreakable law of the universe. But this discovery showed that down at the weird, spooky quantum level, the rules just don't apply in the same way. These quantum systems can pull usable energy right out of the bizarre connection of entanglement. They didn't just break the speed limit, they proved the road was completely different. So how on earth did they do this? They used a really cool technique called quantum echoes. It's kind of like this. Imagine you poke one tiny part of a spider's web. That's the qubit. Then you basically hit rewind on time to see exactly how that little poke made the entire web vibrate and ripple. It's like a controlled butterfly effect, and it lets you see all these tiny connections that were totally invisible before.
And the result of this? It's a total game changer. This technique gives scientists what they're calling a longer molecular ruler. Suddenly, they can see how atoms are talking to each other across huge, complex molecules. We're talking about seeing the blueprint of life with a clarity we've never had before. And that, my friends, opens the door to designing brand new medicines, super efficient catalysts, and materials we've only dreamed of.
So this isn't just some abstract science experiment that stays in the lab. Nope. This is the starting gun for a whole new industrial revolution. We're talking about an exponential acceleration across pretty much every industry you can think of. And when you look at the numbers behind this thing, they are just staggering. Let's try to wrap our heads around the scale here. The Willow chip, it performed over 1 trillion quantum measurements. That's a 1 with 12 zeros. To put that in perspective, that's more calculations than every other quantum computer ever built from all the labs in the world combined. Mind-blowing. And it's not just about doing a lot of stuff, it's about doing it right. The accuracy here is just insane. We're talking 99.97% on a single qubit operation. Now that might not sound like a lot, but in the super messy, noisy world of quantum mechanics, getting that level of precision was something people thought was basically impossible. And that stability, that's the key. Fewer than one error for every 10,000 things it does. This is a huge leap towards what everyone in the field is chasing, fault-tolerant quantum computing. That's the holy grail, right? Building a machine that's so stable it can actually catch and fix its own errors on the fly. That's when things get really interesting. So what does this mean for you and me? Well, the impact is going to be fast. Look at all these fields: drug development, material science, our energy grid, finance, climate science. They're all on the brink of being totally transformed. Think about it. Creating a new drug can take a decade and cost billions. With this, we could be talking about doing it in a few months. That's just one example of how massive this is. Okay, so far it all sounds amazing, right? Here's for diseases, new materials. But here's the turn. With this kind of immense power comes immense risk. This isn't just a simple story of human progress. This is the unveiling of a true double-edged sword, and it's creating a whole new set of global challenges that, frankly, we need to start thinking about right now. And the stakes could not be higher. Let's look at the two sides of the coin. For every promise, there's a peril. Promise? Unbreakable encryption to secure everything. Peril? The ability to break all current encryption overnight. Promise? Cures for terrible diseases. Peril? The tools to design new, targeted bioweapons. The potential for perfectly stable economies, where the power to trigger massive, unpredictable chaos. And if that wasn't enough, let's throw AI into the mix, because what we're seeing is this incredible feedback loop. It's like AI and quantum computing are best friends, helping each other get smarter. The AI designs better quantum chips. The quantum chips then supercharge the AI's training. And you just keep that cycle going. Where does it end? Well, we might see a completely new form of intelligence emerge. One that doesn't just think faster, but thinks differently, using quantum logic at its very core. So, what does this mean for the world stage? It's creating a new and potentially very dangerous geopolitical divide. You're going to have the haves and the have-nots on a whole new level, the quantum-capable versus the quantum-dependent. The nations that get this right, the ones that lead this charge, will basically write the rules for the next 100 years. We're talking about a power imbalance that could dwarf anything that's come before. So, where does all this leave us? The big takeaway is this: the quantum future isn't something we're waiting for anymore. It's not a someday thing. We've crossed the line. The switch has been flipped. This is not a drill. Welcome to the quantum era. And just look at how fast this is all projected to happen now. The timeline has completely collapsed. 2025 was just the proof that it works. By 2026, maybe even 2027, we could have those first fault-tolerant machines. By 2028, you might be able to buy time on a quantum computer commercially. And by 2030, these things could be common tools in labs everywhere. The future is coming at us, and it's coming fast. Look, this is a technology that's going to reshape literally every part of our world, from how we understand a single atom to how the entire global economy functions. So we're left with this one massive question, a question for all of us. The quantum era isn't coming, it's here. So, are we going to rise with it, or are we going to be swept